All right, so the feathers in a pillow have a total mass of 59 grams. The pillow is in the shape of a rectangular prism, measuring 51 centimeters by 66 centimeters by 7 centimeters. A steel anchor is shaped like a square pyramid. Each side of the base measures 20 centimeters, and its height is 28 centimeters. And the anchor's mass is 30 kilograms. We want the density of feathers in kilograms per cubic meter. So, we first, we have the mass of the grams, and we're going to need it in kilograms in order to find the density of the feathers in kilograms. So I'm going to use that 1 kilogram is equivalent to 1,000 grams. I'm going to put this in kilograms. Cross multiplying. And then dividing by 1,000, 59 divided by 1,000 gets me 0.059 kilograms. Now I'm going to find the volume in cubic centimeters of the pillow, length times width times height. So 51 times a 66 times a 7 gets me 23,562, and this is in cubic centimeters. Now we're going to want the density in kilograms per cubic meter, so I do need to transfer the volume from cubic centimeters into cubic meters. So now I'm going to do that conversion. 1 cubic meter is equivalent to 1 million cubic centimeters. So I'm going to be finding the number of cubic meters given this as my volume. Cross multiplying. And then dividing by 1,000,000. I get that my volume is as follows. Okay, so now I can find my density of the feathers in kilograms per cubic meter by doing my mass, which is 0.059, over my volume, which is 0.023562. And I'm going to round my density as approximately 2.50 kilograms per cubic meters. That's my density of the feathers. So now I'm going to find the density of the steel in kilograms per cubic meter. So that's with my anchor. My anchor, we already have our mass given in kilograms, so we don't have to do anything there. Let's find our volume in cubic centimeters of our anchor. The steel is shaped like a square pyramid, so the volume is going to be 1/3 the area of the base, and the base measures 20 by 20, so 20 squared, times the height of your pyramid, which is 28. So a 20 squared times a 28 times a 1/3 gives me that my volume is as follows, and this is in cubic centimeters. So now I need to convert this into cubic meters. I'm going to do it the same way that I did the other one. Cross multiplying. I get that my volume in meters cubed, or cubic meters, is as follows. And this is an approximate, I just rounded. So now my density of the steel is going to be 30 kilograms over 0.0037 meters cubed. So dividing that out, I would wind up with approximately 8,108.11 kilograms per meters cubed. Okay. So then it says, what's the volume of 1,000 kilograms of feathers in cubic meters? So I know the density of feathers in kilograms per cubic meter. So my density, which was approximately 2.5 kilograms per cubic meters, that would be equal to 1,000 kilograms of feathers over my volume, which is what I'm trying to find. Multiplying both sides by the volume, I would have a 2.50 V is equal to 1,000. And then to finish this off, to find the volume from here, I'm going to, and this is going to be rounded, because I already rounded the 2.50, I'm going to divide by 2.50 to get approximately 400 cubic meters. And then what's the volume of 1,000 kilograms of steel in cubic meters? Same thing, I'm going to take my density of the steel, and I'm going to set it equal to 1,000 kilograms of steel over the volume. Same thing, I'm going to multiply both by V. And then dividing both sides, I would get my volume is equal to, or approximately equal to, 0.12 meters cubed. All right. Looking at the next one, we have an aquarium manager drew a blueprint for a cylindrical fish tank. The tank has a vertical tube through the middle in which visitors can stand and view the fish. The best average density for the species of this fish that will go in the tank is 16 fish per 100 gallons of water. So this provides enough room for the fish to swim while making sure there are plenty of fish for people to see. The aquarium currently has 275 fish available to put in the tank, and we want to see, is this number is this the right number of fish? And if not, how many fish should be added or removed? All right, so first we're going to find the volume of this fish tank. And so the volume is going to be the volume of the large cylinder, which is pi, and then my radius is 5 because I have to do the 2 plus the 3, squared times my height, which is 4. And then I'm going to subtract the volume of the inner cylinder, which is pi times 2 squared times 4. So I wind up with a 25 times a 4 minus 4 times a 4, which is an 84 pi. And this is feet cubed. Now, one thing that you need to know is that 1 cubic foot, which is not stated in this problem, is approximately equal to 7.48052 gallons. So I'm going to convert my volume of feet cubed into gallons. So if I do 1 over the 7.48052, that would be equal to an 84 pi times x gallons. So x is going to come out to be approximately, if I do an 84 times a pi times a 7.48052, approximately 1,974, I'm going to round to the nearest hundredth, 0.06 gallons. That would fit in this fish tank. So now we need to see what the safe amount of fish for this water would be, for this aquarium would be. So the safe amount would be 16 fish per 100 gallons of water. We're trying to figure out how many fish per 1,974.06 gallons of water. So I'm going to cross multiply. I wind up with 100y is approximately equal to, because I did round, $31,584.96, and then I'm going to divide by 100. So I get y is approximately equal to 315.85 fish. So it says that they were going to put 275 fish in the fish tank. While that's safe, that's not enough fish for people to see. So we do need to add fish. And I'm going to round down. So I'm going to say that 315 minus 275, we need to add 40 more fish to this fish tank. Okay, so I'm actually going to continue the next page in a new video.